Hello and welcome to this AWS tutorial. In this video, we will talk about how you can use different AWS services together to implement an automated and scalable video processing pipeline without having to manage the underlying infrastructure. This idea of not managing the underlying infrastructure is called serverless. AWS offers a service called Lambda, which provides serverless compute, and it can be more cost efficient to use it than running an EC2 instance 24 hours a day and only do work for a few seconds here and there. However, Lambda functions are limited in duration and hardware resources, which means they cannot be used for complex video processing tasks, and we need to use other services for that, which is what we're going to be doing here. The objective here is to implement a video processing pipeline that will be able to process video recordings uploaded to the cloud asynchronously and without having to manage instances. The workflow that we will implement here consists of converting a colored movie into the corresponding grayscale movie, and we want this entire process to automatically happen as soon as a file is uploaded to an S3 storage bucket. To implement this, we will use the following technologies and services. Python will be used to write the code responsible for converting the movie from RGB to grayscale. Docker will be used to create a blueprint of the processing instance. This blueprint will get stored on the Elastic Container Registry, ECR. Then the Elastic Container Service will be used in conjunction with Fargate to manage, scale, and deploy the processing containers. Lambda will be used to monitor and trigger processing upon file upload to an S3 bucket. This schematic shows how the different services interact with one another. We upload a file to S3. The Lambda function detects it and triggers a new processing task on the ECS service, which uses our template image to launch new processing containers. The output data is then stored back onto S3. There are some limitations with the approach that we will be using that I want to point out. One is that the processing code lives within a static Docker image. This essentially means every time you make a change to your Python processing script, you need to rebuild the Docker image and push it to ECR and potentially update the version of the image to use in your ECS tasks. Another thing to keep in mind is that we are transferring files to S3, then copying them over to processing containers, and then transferring the results from those containers back to S3. This creates a lot of data transfer, and for large files, this may not be optimal in terms of cost. I also want to mention that this is not the only way to implement asynchronous batch processing, so I would recommend comparing the performance, portability, and cost associated with different batch processing solutions and container management services. Kubernetes and AWS batch processing are other services that could be used to implement this workflow. Let's dive right in and go through the process of setting this up one service at a time. There are two prerequisites for this demo. First, you will need an AWS account with sufficient permissions to use the different services that we will be covering in this tutorial. Second, I would recommend installing AWS command line interface so that you can run commands on AWS from your local machine. The following webpage provides instructions for installing this tool on the different operating systems. We're now going to create folders to store our data. From the management console, select the S3 service. Click Create Bucket to create a new bucket. We're going to call the first one Video Processor Input. This is where we're going to be uploading our video files to. You can leave all the settings to their default values. We're going to leave the bucket private. We don't need public access for this. Create a second bucket by clicking Create Bucket. Call it Video Processor Output. This is where we're going to be storing the processed video files. Again, we're going to leave all the settings to their default values. We're now going to create the Python program responsible for processing the video recordings. First, create a folder called code, and then create two files within that folder, one called requirements.txt and the other process_video.py. The requirements file will be used to store the Python dependencies for our program, as listed here, and the process video file will be responsible for converting a colored movie into the corresponding grayscale movie. And here we have the code, which will be provided along with this recording. So at the top you have a function that's using OpenCV to convert the RGB movie to a grayscale movie. And then we're using the click command line interface to automatically generate a program that we can run from the command line. And this is what we're going to be using in our Docker container later on. And what this program does is it first downloads an input movie from S3. It converts the movie to the corresponding grayscale movie, and then it uploads it back to S3. We're now going to create the blueprint for the containers that we're going to be spinning up on AWS. To do so, you're going to create a new file called Dockerfile without a file extension in the same folder where you have your Python script and your requirements file. And then you're going to add this code, which is also going to be provided with this recording. What this code does is it essentially installs FFmpeg, which is a video processing software, and then it invokes the Python program with the arguments that we're going to be passing to this container. So this container expects 4 arguments: the name of the input bucket, the name of the output bucket, and the file names for the input and output files. And these are going to be provided by the Lambda function that's going to be running tasks on these containers upon file upload to S3. To build the Docker image, you will need to make sure you have Docker installed on your machine. Once you have it, open a terminal and browse to the location of those 3 files. You can use the following command to verify that Docker is properly installed and see the version that you have. To build the Docker image, run the following command. Once the image is ready, you can check the list of images on your local machine by typing Docker images as follows. Now let's create an ECR repository to store our image. Open the Amazon Elastic Container Registry service and click Get Started to begin the process. We're going to create a private repository and call it Video Processor so that it matches the name of the image that we just created. We're going to leave all the settings to their default values. Browse to the bottom and click Create Repository. To push your local image to this repository, select the repository and click View Push Commands. This is going to show you the different commands that you need to run sequentially in order to push your local image to this online repository. In order to run these commands, you will need to make sure that you have AWS CLI installed on your local machine and that your user has programmatic access to AWS services. You can gain access by visiting the IAM page. Under your user account, you can go to the Security Credentials tab, browse to the Access Keys section, create a new access key, and download the credentials, which you will be able to configure in the terminal by typing AWS configure and copy-pasting the access key and the secret key. Once you have this set up, run the push command sequentially. The first command will authenticate your Docker client to your registry. Since we've already built our image, we're going to go ahead and skip step number 2 and move on to step 3, which is about tagging our image using the following command. Finally, let's push our image to ECR. We're now going to use the Elastic Container Service to deploy, manage, and scale Docker containers. And rather than setting up everything separately, we can take advantage of the Get Started button and do it all at once, right here. So this is going to allow us to create the task, service, and the cluster all at once. First, let's configure the container definition. So we're going to choose Custom and click Configure. Container name, we're going to use Video Processor, the same thing that we used for our image. And here we're going to want to paste the URL to the image that we pushed to ECR a second ago. So in order to get this full path, you can go back to the ECR service and click the Copy URI icon, and then paste it here. We're going to leave the other settings to their default values. Click Update. Next, we're going to update the task definition name to give it a meaningful name. We're going to call it Video Processor Task Definition. And again, we're going to leave everything to default values. And then click Next. We're going to use the default service. Click Next. And here we're going to give our cluster a name. Click Next. Finally, we're going to get to this page where you can review the configuration for your cluster and make sure that everything looks right. And once you're ready, click Create to create the cluster. Our cluster is now ready. As you can see, the cluster is active. We're using Fargate to manage the underlying containers, and it automatically created a service role for us. Let's now configure the access policies and roles that are going to be needed for this workflow. The first thing we're going to need is a policy that gives us read access to the S3 input bucket and write access to the S3 output bucket. To create that policy, browse to the Identity and Access Management service and click Policy. We're going to use the JSON tab because we're going to be pasting our access policy right in there. So read access to the input bucket and write access to the output bucket. We're not going to use any tags. We're going to call it video processor S3 policy and leave the description field blank and hit create policy to finish. Next, let's create a role that will allow our ECS tasks to call AWS services such as S3 on our behalf. Go to the roles tab here. We're going to create a new role. We're going to select the Elastic Container Service here, and then we're going to select Elastic Container Service tasks and click Next. We're going to attach two policies to this role. The first one is going to be the S3 policy that we just defined, and the other one is going to be the SSM policy that's going to give this role access to our credentials so that it can run these different services. So let's go here and find our S3 policy. And then let's find the SSM policy. Here it is. And click Next. We're not going to add any tags. We're going to call this role ECS task role video processor. I'm going to click Create Role. Let's now create the Lambda function that will be responsible for triggering video processing upon file upload to S3. To do so, open the AWS Lambda service and click Create Function. We're going to select the option Author from Scratch. Give it a name such as Video Processor S3 Upload Trigger. We're going to use Python 3.9 for the runtime. Under Permissions, make sure to expand this little arrow, and we're going to create a new role from AWS Policy Templates. We're going to give it a name, Lambda Video Processor S3 role, and here we're going to give it S3 read-only permission. And finally, click Create Function to create your Lambda function. Let's add a trigger to this function by clicking Add Trigger. I'm going to select S3 and the input bucket. And then under event type, make sure that you select all object create events, and this is going to trigger this Lambda function for every file uploaded to this S3 bucket. Then you have to click the checkbox to acknowledge and click Add. By default, the Lambda function will not have sufficient permission to run an ECS task on your behalf. To give it the appropriate permissions, select the Configuration tab and then select Permissions from the panel on the left-hand side. From here, you can click on the name of the role, which is going to open the Identity and Access Management service. We're now going to attach a new policy to this role. And the policy that we're looking for is called ECS Full Access right here. Click Attach Policy. And this will now give our Lambda function sufficient permissions to run ECS tasks on our behalf. The final step to define this Lambda function is to add code to it. So let's go back to this Lambda function, click the Code tab, and then if you browse down, you'll see that right now we only have a simple hello world function. We're going to replace this with the following code, which will be provided along with this recording. So let's go over the code, see what it's doing. So first of all, we're defining the location of our input and output buckets. Then we're going to be retrieving the key, which is the file name, the name of the input file. Then we're going to be constructing the output file name, which consists of the input file name plus the suffix processed. Then we're going to print these variables to the console so that we can see them in the log. And then here we're going to be creating a new task on the ECS service, and we're going to run that in a Fargate cluster. There are two things here that you're going to want to make sure that you update properly. First of all, the task definition. Here you'll notice that there is a :3 at the end, and this is because this is the third time that I'm configuring this task, and so it has version number 3. In your case, the version number might be slightly different. And the other thing is the task role ARN, which is unique to your account, so you will need to make sure that you update your account number. And then here at the bottom, we're overriding the input parameters to the container. The last thing that you're going to need to update are the subnets ID shown here, and you can get that information by going to the VPC management console. And if you click on subnets, you'll see that there are 2 subnets that are associated with our ECS video processor cluster. So these are the subnet IDs that you're going to want to copy into your Lambda function. Now click deploy to deploy your changes. Our Lambda function is now configured. We're now ready to test our system. So to do that, what we're going to do is we're going to upload 5 colored videos to our input bucket, and then we're going to wait a little bit, and then we're going to take a look at the output bucket where we expect to see the same 5 videos in grayscale. Open the Amazon S3 service and open the input bucket. Now let's upload the 5 recordings. You can just drag and drop them here. Click upload. Now that the files are uploaded, we can check that the Lambda function was invoked once for each file. If you go back to this Lambda function and you click on the monitor tab and you scroll down, you'll see that there's a dot here indicating that the function was invoked, and it lines up with the current time. If you click on view logs in CloudWatch and select the latest log, you'll see that indeed the Lambda function was invoked for every file that we uploaded 5 times. Now if we check the ECS service and we go to our cluster, under the task tab, you'll see that there's 5 extra tasks that are running, and there's basically 1 task for each file that we uploaded. If we open one of them, it's going to remain in the running status until it finishes processing. You can click on the refresh button here. Once the task completes, the status will be updated to stopped. At that point, you can go up to the logs tab and see the logs for the particular file that was processed. And if we go back to S3 and take a look at the output bucket, as expected, we now have 5 processed recordings. We can download one of them and take a look at it by clicking download. We open this recording. As you can see, we now have a grayscale movie. So this is how you can use services such as ECS, Fargate, Lambda, and S3 together as a generalizable alternative to Lambda functions for more complex jobs that require longer processing time. Thank you for watching.